Hi, today we are going to be learning another method for solving systems of equations. Today we are going to be doing it algebraically using substitution. So today we are solving systems of equations using substitution. Okay, so we want to divide our page up. And so we're trying to find the solution to 2x minus 3y equals negative 3 and y equals negative 3x minus 10. So this is set up for substitution because we know what y equals. One of our equations is already solved for y. And so it makes it really easy to use substitution. So what you're going to do is you're going to take what x or y equals in one equation and substitute it into the other. Okay, so we know what y equals. Y is equal to negative 3x minus 10. It's equivalent. This is y. Y is negative 3x minus 10. So you're going to circle what y equals. We can use y and negative 3x minus 10 interchangeably because they are equivalent. And so we're going to plug it in for the y in our first equation. So we have 2x minus 3 times y, but we know what y is. Y is negative 3x minus 10. And that's going to equal negative 3. And so now we just solved the equation. So we have 2x minus 3 times negative 3x minus 10 equals negative 3. So you got to follow the order of operations. So PEMDAS, we have to do our parentheses first, which means we need to distribute. So negative 3 times negative 3x, that's a positive 9x. And negative 3 times negative 10, that is a positive 30. And then we're going to bring everything else down. So we have 2x plus 9x plus 30 equals negative 3. So again, we're using our solving equations skills, and we have like terms on the left side of our equation. So we need to combine our like terms first. So we have 2x and 9x, which gives us 11x plus 30 equals negative 3. Got to get x all by itself, so we're going to subtract 30 from both sides. Those cancel out. We bring down 11x equals negative 3 minus 30, which is negative 33. Then we solve for x by dividing both sides by 11. So those cancel out, leaving us with x equals negative 33 divided by 11, which is -3. Is that where the lines cross? Well, partly, we know they cross at somewhere on x equals -3, but we need to find the y value now for the point where they cross. So now we are going to substitute that value into one equation and solve for the variable. So again, it doesn't matter which equation you choose. Pick the one that's easier for you. I think y equals -3x minus 10 is easier because we already are solving for y. So I'm going to copy that down. Y equals -3x minus 10. So again, you're just picking one of your two original equations, and we are going to substitute x equals -3. And we're going to solve for y now. So y equals -3. But instead of writing x, we know what x is. X is -3 minus 10. So y equals -3 times -3 is +9. 9 minus 10. So y equals -1. So now we are going to write the solution as a coordinate point. How do we do that? We write it as x, comma, y as a point. So our solution is, remember to write x first, so -3, and then y, which is -1. And our last step, we're going to check our answer. So we have 2x minus 3y equals -3, and then y equals -3x minus 10. Again, I'm just copying down the original two equations we were given. I'm going to use -3 for x and -1 for y. So we're going to prove that these are, in fact, the solution, that they make both equations true. So 2 times x, which is -3, minus 3 times y, which is -1, equals -3. 2 times -3 is -6. -3 times -1 is +3. That should equal -3. -6 plus 3 is -3, equals -3. Makes that equation true. And then we have y, which is -1, equals -3 times x, which is -3 minus 10. -3 times -3 is +9, and +9 minus 10 is -1. Made both equations true. So the point where these two lines cross with 100% certainty is -3, -1. Okay, let's practice this on your solving systems of equations using substitution assignment. Okay, so we're going to use substitution to solve. So number 1, we have y equals negative 3x plus 10, and negative 2x plus 3y equals negative 3. So step 1 says to take what x or y equals in one equation and substitute it into the other equation. So which one is solved? That's this one, the first equation. We know y equals negative 3x plus 10. And we're going to substitute that in for the y in our other equation. So we have negative 2x plus 3 times y, but we know what y is. Y is negative 3x plus 10. And that's going to equal negative 3. This one is awfully similar to the one in our notes. Let's go ahead and do number 2. You can finish one on your own. I'm going to go ahead and do number 2 with you. So we know that y is equal to negative 3x plus 5. So this is the equivalent of y. So we're going to take this and we're going to substitute it into the y in our top equation. So we have 3x minus 4 times y, but we know what is equivalent to y is negative 3x plus 5. We're going to substitute that in, and that's going to equal 10. Then we need to solve for x. So first we need to distribute. So negative 4 times negative 3x is positive 12x. And negative 4 times positive 5 is negative 20. Then we bring everything else down. So we bring down the 3x, and it equals 10. Then we're going to solve for x. So first we have to combine our like terms. So 3x plus 12x is 15x minus 20 equals 10. Add 20 to both sides. (15x) equals 30. Divide both sides by 15. And x equals 2. We're halfway there. We know what x is. We need to find y. So I'm going to use my equation that solved for y. And I'm going to substitute in my x value to solve for y. So y equals negative 3 times 2 plus 5. Negative 3 times 2 is negative 6. Negative 6 plus 5 is negative 1. So y equals negative 1. So then step 4, we write the solution as a coordinate point. So x first and then y. So our solution is 2, negative 1. Then we're going to check our answers. We're going to prove that this is the point that makes both equations true. Copy down both of your original equations. Just the 2 that were printed for number 2. And then we're going to substitute in 2 for x and negative 1 for y. So we have 3 times x, which is 2, minus 4 times y, which is negative 1. Equals 10. We simplify. 3 times 2 is 6. Negative 4 times negative 1 is positive 4. Does that equal 10? Yes, 10 equals 10. Y equals negative 3x plus 5. So y is negative 1 equals negative 3 times x, which in this case is positive 2, plus 5. So negative 1 equals negative 3 times 2, which is negative 6. And negative 6 plus 5 is negative 1. It makes both equations true. So we know we solved correctly, and that the solution 100% is 2, -1. Okay, go ahead and solve using substitution and make sure to check your answers.